Hello, my name is Taylor Talley, and I've been working with PhD candidate Matthew Pearson and principal investigator Dr. Jeremiah Johnson to develop a hybrid polymer-MOC material with accessible permanent porosity that could give more favorable mechanical properties. The monomer was synthesized from starting material 5-hydroxy isophthalic acid, which underwent a Fischer esterification, an SN2 reaction, a Bock deprotection, and a nucleophilic acyl substitution. To characterize the monomer, an hydrogen NMR was taken, which then verified the synthesis of our monomer. After synthesizing our monomer, we then polymerized the monomer to make a polymer. We removed an N group on our polymer. We hydrolyzed the polymer, and then we created hybrid polymer metal organic cages. To synthesize the polymer, a RAFT reagent and radical initiator was utilized. Then, for characterization purposes, the hydrogen NMR was taken to verify the material created. After the polymerization was verified, a kinetics experiment was performed. We aimed for a specific molecular weight or percent conversion. We aimed for a 60% conversion due to wanting low dispersity within the polymer. If we were to aim for a higher percent conversion, such as 80%, we would risk bimolecular coupling. After the kinetics experiment was completed, a gel permeation chromatography trace and a hydrogen NMR was taken. The GPC shows a unimodal curve which indicates a uniform molecular weight distribution among the polymer, and the polydispersity index, or PDI, was calculated to have a low dispersity. The next step in the project was to remove the N group. The graph on the left indicates the removal and the presence of the triethyl-carbonate group. The black line indicates the triethyl-carbonate group being present, while the red line indicates the removal of the triethyl-carbonate group. After the removal of the triethyl-carbonate group was verified, a hydrolysis then occurred, which is characterized by the hydrogen NMR. Once the hydrolysis was confirmed, we then experimented with 3 possible metal organic cages. In 3 separate reactions, isophthalic acid was used with rhodium acetate dimer, a copper nitrate hemipentahydrate, and a copper acetate monohydrate. After observation, the experimental reaction with copper nitrate hemipentahydrate was the only reaction to form crystals. After crystal formation was observed, the polymer was then incorporated with the metal organic cages. We completed 3 separate reactions of stoichiometric ratios for free ligand to polymer bound ligand. The ratios were 2:1, 5:1, 11:1 free ligand to polymer bound ligand. After the reactions were completed, a powder X-ray diffraction, or PXRD, was taken of the ending material, and it indicated that increasing the amount of polymer disrupts the crystallinity within the metal organic cages. This research then lays the foundation for the development of bulk copper and rhodium poly-MOC materials.